All right, everyone. So I'm going to, for number 10, we're going to be using two functions of the calculator. We're going to be using the binomial PDF and the binomial CDF functions of the calculator. So let's take a look at what the problem gives us for number 10. So in number 10, hold on, let me get a clean one. So in number 10, we're told that 67% of the adults have very little confidence in newspapers. You randomly select 10 U.S. adults, find the probability that the number of U.S. adults who have very little confidence in newspapers is exactly 5, at least 6, and less than 4. So I'm going to use another sheet of paper, and we're going to be looking at the keystrokes for binomial PDF, binomial CDF, and how do I know which one to use when presented with a problem this way. So let's start off with getting the camera in focus. Okay, so number 10, and we're using the binomial PDF and binomial CDF functions in the calculator. Okay, so we still need 3 pieces of information. So from number 10, I'm going to bring that back. In number 10, we know that 67% of the adults have very little confidence in newspapers. That's pertinent information because in a binomial experiment, we know that there are 2 outcomes. Our 2 outcomes are very little confidence, and then the converse of that, having confidence. So 67% of the U.S. adults have very little confidence. So I'm going to write that as P of little confidence equals 67%, or as a decimal, 0.67, right? That means that the converse of that, or Q, would equal 1 minus 0.67, which is 0.33. Okay? Because remember, Q is the complement. If 67% have very little confidence, then 33% have confidence. Okay? We also know that 10 randomly selected adults. There were 10 randomly selected adults. So we know N equals 10. We need to calculate the probability of, out of those 10 adults, 5 of them had little confidence, at least 6 of them had little confidence, or less than 4 of them had little confidence. So for this, we're going to be using the binomial functions of the calculator. And so here, for P of 5, that is exactly one value, then I'm going to use the binomial PDF. So I'm going to demonstrate that here. So I'm going to move here. So to find P of exactly one value, use binomial PDF. Okay, so for us, that's P of 5. Now, what we know is that n equals 10, p equals 0.67, q equals 0.33, and x equals 5. That's what we know. For the purpose of our calculator, we're going to use the following. We're going to use n, we're going to use p, and we're going to use 5, or x, I'm sorry, x. So now let's go to the calculator. I'm going to demonstrate, and we're going to write the notes for what happens. So, for my calculator, zoom that in a little bit. Too much. Let's go about there. For our calculator, we're using the distribution function in our calculator. It is yellow, so to access it, we have to press second. Okay? So I'm going to press second and vars. I want to scroll down in my calculator. Be careful, we're not using the normal PDF or normal CDF. We need binomial. Okay? You see where they are. So for binomial, gone too far. Binomial PDF, I need option 0. Binomial PDF. Okay? So I'm going to choose option 0. I can go right there and select it by pressing enter. Press enter. Now it opens up a parenthesis, because now it's asking for you to key in the information. The calculator is saying, well, find the binomial PDF of what? Here's where we enter our values in this order: n, comma, p, comma, x. N, which is 10, comma, p, which is 0.67, comma, 5. I'm going to close the parentheses and press enter. Alright? So we get this value. This is the probability that exactly 5 people have very little confidence in the local newspaper based off of the information given. Well, I'm going to round this. I'm going to write out on my record rather 0.1332, and then I'll round from there. So the probability of exactly 5 people, 0.1332, and rounding that to the nearest 3 numbers after the decimal gets us 0.133. Okay? I use PDF when I have exactly 1 value. Let's write out the steps. First thing, identify. So even before I go to my calculator, identify N, P, and X, because you need those 3 variables. Okay? 2. Now I'm at the calculator. I press second. I'm sorry. I don't want to write the word second. Sorry guys. Hold on just a minute. Hold what you got. Second, okay, vars, that's the key, vars, V-A-R-S, okay, and then you choose option 0. Let's look at that. Let's redo that. Make sure we can get that far. Second, bars. Scroll down. Option 0, press enter. Okay? And then press enter. Alright. And then enter N, P, and X. I'm going to put here, make sure you use the comma. Use commas. Okay? And then last you press enter. That's the key. Okay? So those are the steps to keying that in. Now, the next one, let's look at the next one. The next one says for us to find the probability of X is greater than or equal to 6. Okay? So we just found exactly 5, one number, and we used the PDF. But for when you have these symbols, I have options. I could go in greater than or equal to 6 means the probability of 6, exactly 6, plus the probability of exactly 7, exactly 8, exactly 9, exactly 10. I could do that, okay? And using the PDF function. I also can process in my mind, well, greater than or equal to 6 is the same as what? Because the calculator, the CDF function, allows me to use to find cumulative. That means the adding up of several different probabilities. However, it does not process this symbol. Okay, y'all stay with me. It doesn't process this symbol. It processes only the less than or equal to. So let's look at what I mean. So we need the probability of X is greater than or equal to 6. That is 6, 7, 8, 9, and 10. Well, let's think about what it is not. Okay? So what it is not, or what numbers are not included here, are 0, 1, 2, 3, 4, and 5. So I need to try to write this inequality statement using another symbol, using the less than symbol that will include these values so that I may be able to use my calculator. So when I think about the probability of X is greater than or equal to 6, and I want to be able to use a less than symbol, okay? So X is less than or equal to something that's gonna make me get these numbers. Well, all the numbers that are not being used right now, so I'm gonna list here numbers not used. The numbers not used are 5, 4, 3, 2, and 1, and 0. So remember, I told you we could go in and find the probability of 6 exactly, 7, 8, 9, and 10 and add them up. But I could use that idea of the complement. Let's see, if x is greater than or equal to 6, the complement is all of these numbers. Well, that is x is less than or equal to 5. That means 5 or less. Well, that's the complement. I want to connect. How can we use the complement to find probability? Well, I know that 1 minus the complement, in this case x is less than 5, would equal the actual numbers that I want, which are x is greater than or equal to 6. Okay, let's process what's happening. This is what we're trying to calculate. We're going in a backdoor fashion so that we can use the calculator. The calculator will not calculate greater than or equal to 6 using either the PDF or the CDF function. It only uses this, it will not use this greater than symbol. So what we have to do is figure out, well, what is the complement of that? And I do that by figuring out, well, what numbers am I not using? I'm not using 5, 4, 3, 2, and 1 and 0. Well, if I take those numbers away from the total outcomes, 1 minus that, I should get this one. This I can put in my calculator. I can put this one in my calculator. Okay? So, let's look at what we're going to put in our calculator. So, we're going to use, so let's use the same directions or style of note taking. So to find P of x is greater than or equal to 6, we're going to use 1 minus P of x is less than or equal to 5. And that's going to allow us to use the binomial CDF function. It can only be used with the less than or equal to symbol. Only used with less than or equal to. Alright, let me remind you, you can go in and do what we did earlier and find the probability of exactly 6, exactly 7, exactly 8, exactly 9, exactly 10, and add those up using the probability, the binomial PDF. Or we can use this method and use the binomial CDF. So let's go to our calculator. So on my calculator, okay, get that in view. So I go second, okay, well, I'm sorry, not second, because I need to do this is my work. 1 minus, so 1 minus, I'm going to open up a parenthesis. I don't know if I really have to, but let's see. 1 minus, and now I'm going to do second vars. Scroll down, and this time I want binomial CDF. Choose binomial CDF. Press enter. Now, just like before, I need to enter in n, which is 10, comma 0.67, which is the probability of the people having very little confidence in the newspaper. And here I'm going to enter in the number 5, because remember, we're using the complement. Now look at this number. So we have found, using the complement, the probability of at least 6 people having confidence in the newspaper, very little confidence in the newspaper. So looking at that number, 0.7936, this 4 doesn't bump that 6 up to a 7, I'm sorry. So I'm going to record P of X is greater than or equal to 6 as 0.7936, rounding that to 3 numbers after the decimal, 0.794. Okay. Remember, if the question, let's recap, how did I even get to this if this is what I'm being asked for? The problem asks for us to find the probability of X is greater than or equal to 6. That means I'm wanting the probability of these values. What could I have done? I could have used the process from above and found the probability of exactly 6, added that to the probability of exactly 7, exactly 8, exactly 9, exactly 10, and I would have gotten to this number. Or I can consider, if I want these numbers, what am I not considering? I'm not using the numbers 5 and less and lower than 5 inclusively, including 5. So I can rewrite this statement as X. I can rewrite the complement, however, as X is less than or equal to 5. Remember, less than or equal to, X can be 5 and X can be everything smaller than 5. Well, then I can write this statement to represent what I really want, because 1 minus this value should equal X is greater than or equal to 6. Okay? Okay. So then I use my calculator using the same keystrokes, and we're going to write those out. The first thing I did, I didn't have to identify N, P, and X here. I already had it, but in general I need to identify N, P, and X. But I also, before I go to my calculator, I needed to rewrite the inequality statement to represent the complement. Write an inequality using the less than or equal to symbol to represent the complement. Let me reiterate what I mean. This is what we were looking for. X is greater than or equal to 6. That's these numbers. These are the complement. That means the ones that we're not using. So I rewrote an inequality symbol, inequality to represent these numbers. 5 or less looks like this. In the calculator, I'm now calculating 1 minus 5 or less to give me everything bigger than 5. including 6, which would be bigger than 5. Everything bigger than 5. So that's 6, 7, 8, 9, and 10. So I then go to my calculator. I go to the calculator and I press second, bars. This time I want option A. I press enter. And I enter N, P, and X. This time X will be from the complement. And then I press enter. Okay. Alright. The next one is we're going to find P is less than 4. So you see we have one where we had the greater than or equal to symbol. Now we're going to look at, well, what do I do when I have a less than symbol? Let's bring that out of the zoom a little bit. Focus. Alright, so to find P of X is less than 4. Well, what are, so the calculator does not process less than 4. It knows in the CDF function. When you use the CDF function, it is processing less than or equal to whatever the number is. So you either got the exact value or a less than or equal to value. So we want X is less than 4. Well, what are those numbers? That is not 4. Oh, I'm sorry. It's not focused. So X is less than 4 does not include 4. So we're talking about the numbers 3, 2, 1, and 0. Can we rewrite this using an inequality symbol, using the less than or equal to inequality symbol to represent this set of numbers? I'm going to pause and see if you can write an inequality statement using the less than or equal to symbol to represent this set of numbers. Okay, so if P of X is less than 4 is representing these set of numbers, I can write that as P of X is less than or equal to 3. This represents this set, and now I have use the inequality symbol less than or equal to. I can use the CDF function in the calculator. So use binomial CDF. Let me think back to how did I get here. Well, this is what I was asked to find. X is less than 4. Well, the numbers that are less than 4 include 3, 2, 1, and 0 for this context. Well, 3, 2, 1, and 0 can be expressed as X is less than or equal to 3, because X can be 3 and it can be everything less than 3. And since I can write it with that inequality symbol, I can use the binomial CDF function. Okay? CDF function. So let's go to our calculator. And in the calculator, let's call out what we're going to press. Okay. We need to press second, bars. We need option A for CDF. I went too far. Let's go back up. Okay. Press enter. Let's enter in the value of n, which is 10, comma, the probability 0.67, comma, and now because we're doing cumulative, the CDF, we're going to use the value of 3. We want to use the number that's involved in that less than or equal to statement. Be a 3. Close the parenthesis. Press enter. Okay. I see 0.01854. I'm going to record 0.0185. So P of X is less than 4, approximately 0.0185. That rounds to 3 numbers after the decimal as 0.019. Okay. All right. Let's take a look at number 11. Number 11 is similar in nature. I'm simply going to first let me write out when we look at number 9, let's just look at what the answers are, because we want to make sure we know what our answers are for number 9. I'm sorry, not number 9, but number 11. Number 11. Okay. So for number 11, we're asked, let's get to the problem. I want you to see the similarities to number 10, excuse me. Okay? Zoom in a little bit there. Alright. So it says 37% of adults say cashews are their favorite kind of nut. You randomly select 12 adults and ask each to name his or her favorite nut. Find the probability that the number who say cashews are their favorite nut is exactly 3, at least 4, and at most 2. If convenient, use technology to find the probabilities. It is convenient. We will use technology to find the probability. Now, the biggest hurdle, I believe, is making sure we know when to use PDF, when to use CDF. Additionally, if my probability, if they're asking for one that is not in the form of X is less than a number, how do I transform that to rewrite it in the form of X is less than a number, or use that complement? That's what we want to look for opportunities for. But let's start off with what we know. We know that 37% of adults say cashews are their favorite kind of nut. In a binomial experiment, for this context, we know that the two outcomes are either cashews are their favorite or cashews are not their favorite. Another type of nut is their favorite. And so we have P. P of cashews as a favorite. Cashews are favorite is 0.37%. We also know that 12 people were randomly selected. That is our N. N equals 12. What about our complement? First, if there are 37% of the people that like cashews, that's their favorite, how many people don't like cashews? Well, we can find that by subtracting 1 minus 0.37, which is 0.63%, or 0.63, or 63%. Okay? Alright, now remember, for exactly, which function are we going to use in our calculator? That's right, we're going to use our PDF function. So I'm going to get another sheet of paper. We're working on, this is problem 11. Get me set up here. Okay. Alright. Alright, so to find the probability of exactly 3 people that think cashews are their favorite, we're using our PDF function, binomial PDF. So that means we need the following information. We need N. N is 12. We need P. P is 0.33. I'm sorry, y'all, 0.37. 0.37. And then we need X. X is 3. Alright, let's go to our calculator. And let's calculate the probability of 3 people having cashews as a favorite. Second, bars, option 0. Okay. Enter in that order N, P, and X. N is 12, comma. P is 0.37, comma. X is 3. Close the parenthesis and press enter. So here is the probability that 3 people will enjoy our cashews. I'm sorry, everyone. I lost my train of thought. We'll enjoy cashews. Okay. So let's look at how we're going to round that value. Be thinking about what would you record based off of the directions, which are to round to the nearest thousand. That is 3 numbers after the decimal, the nearest thousand. 3 numbers after the decimal. What would you be rounding to? Hopefully you said that our final answer, first I may record 0.1742. Okay, so P of 3, 0.1742, rounded to the nearest 3 numbers after the decimal, a thousandths place, 0.174. Okay. All right. So now let's look at the probability of greater than x is greater than 4. Probability of x is greater than 4. I'm going to think through what are those values that x is greater than 4. What are we talking about? We're talking about x can be 4 because it's equal to 5, 6, 7, 8, 9, 10, 11, and 12. Remember, you have an option. You can go in and find exactly P of 4, P of 5, 6, so forth and so on up to 12, and then add those up. Or we can use I believe a simpler way of finding out, well, what am I not using here? What numbers am I not? And then I can take those away by subtracting that from 1. Well, it looks like the numbers that we're not using or not being included are the following: 3, 2, 1, and 0. Well, can I write an inequality statement using the less than symbol to represent these values? Well, what would that be? X is less than or equal to, because x can be 3 and it can be everything less than 3. So here is my complement. But what do I do with the complement? I subtract the complement from 1 to get the rest of the values. So let's subtract. 1 minus the probability of x is less than or equal to 3 will equal the probability of x is greater than or equal to 4. I need that for my CDF function in the calculator. Remember, the CDF function only works for less than. So now I can use the CDF function for this. That's what you're going to put in your calculator. So let's go to our calculator. So in the calculator, we can see all of it. Okay, so I'm going to start off with 1 minus. Okay, can y'all see that? Looks like it's a little low. Okay. Okay, 1 minus. Now, 1 minus what? 1 minus the binomial CDF of x is less than 3. So, second, vars, CDF. The CDF of what? When n is 12, the probability is 0.37 and x is less than 3. and I'm going to press enter. Okay, so here, look at what I'm going to record. 0.7053 is what I'm going to write on my paper. So the P of X is greater than 4, 0.7053, rounded to the nearest thousandths, that's 3 numbers after the decimal, 0.705. Right? I had to use the complement because I have that greater than symbol. I'm sorry. I had to use the complement because I had the greater than symbol. But when we look at the next part, part C, I don't have to use the complement because this one is already written using the less than or equal to symbol. So P of X is less than or equal to 2. You got options. What numbers are less than or equal to 2? Those numbers are 2, 1, and 0. You could find the probability using the PDF function of exactly 2 added to the PDF function of exactly 1 and exactly 0. Add those up. Or since it's already in that inequality symbol less than, I can use the CDF function, binomial CDF, in my calculator. So let's go to it. So P of X is less than or equal to 2. It's going to be equal to, and we have those steps already written, so you can refer back to that. I'm just going to do it, the keystrokes in my calculator. I don't need 1 minus this time because we're not finding the complement. We didn't need the complement. So second bars CDF of 12, the probability 0.37, and X is less than or equal to 2. I see, should see that, 0.1205, because this 5 is going to make the 4 round up. That's what I'm going to record on my paper first. 0.1205, but as to follow the directions of the problem, 0.120. I'm sorry, not 120. It should be 0.121. So here, guys, let me talk about that. So I'm looking at the answer that was given in the process from the platform. So the answer from the platform is this one. So answer from program. Let's talk about the difference. So here in my calculator, I'm going to bring it back. Y'all see right here? When I rounded that to 4 numbers after the decimal, that makes that go to 5. But when this goes to 5, it makes this go to 1. But that's not the answer that they're wanting. So it means that actually gives me some insight. So right here, when I need to round to that nearest thousandth place from my calculator. So when I do that, that means I need to look at the 4th place. Well, since it's a 4, this doesn't go to 1. So the answer that I'm going to record is 0.120. Okay? So for future reference, let's record this as 4. For future reference, round. If once you get your answer in your calculator for this type of problem, round from the calculator from that place value that you're given. So don't round it and round again. That possibly could incur an error. So just be careful with that. Okay. All right. So that's number 11. We have 2 more, and then we'll wrap it up. So for numbers, for number 12 is done just like what we did in class. And so for number 12, I would ask for you to refer back to what we did for number 8. For number 8, okay? Let me make sure it's probability distribution and not, I'm sorry, binomial distribution and not probability. Yeah. Refer back to what we did in number 8 when we found variance and when we found standard deviation and things like that. But I'm still going to go through that, okay? So for number 12, let's look at the problem for number 12. It says 77% of U.S. adults think that political correctness is a problem in America today. You randomly select 6 U.S. adults and ask them whether they think political correctness is a problem in America today. The random variable represents the number of U.S. adults who think the political correctness is a problem today. Answer the questions below. Find the mean of the binomial distribution. Then find the variance and then find the standard deviation. We then will interpret the information that we found by stating most samples of 6 adults would differ from the mean by no more than blank. Okay? So let's start. I'm going to keep this up here, use the bottom of this paper. So the first thing we're doing is finding our mean. Then we're going to find our variance. And then find our standard deviation. Remember, the mean is mu. Looks like a funny looking, like a cursive U. Variance is sigma squared. And the standard deviation is sigma. Alright. Recall that in problem 8, I believe it was, we calculated our mean. If you refer back into your problem, we found the mean using a formula. So I just wanted to bring back what we did in number 8 in class. Remember, y'all, we did that one in class in number 8. We're going to do this, employ this same process. Okay, so what do we know from this situation? What do we know from this context? What we do know is in order to find all of these, we need N, P, and Q. So let's identify what those are. So I'm going to go back up here to the context. N, P, and Q. How many people were surveyed, y'all? Yeah, here it is right there. Selected rather, not surveyed. Six adults. So N equals 6. Okay. What is the probability that the adults believe that political correctness is a problem? It's right here. 77% believe that political correctness is a problem. 0.77. Well, if they believe it is a problem, how many believe it is not a problem? It's the subtraction of 1 minus 0.77. So Q then equals 0.23. Okay, so we got our N, P, and Q. Let's go down and find our mean, variance, and standard deviation. Alright, for the mean, remember mu is found by multiplying the number of trials times the probability of the favorable part of the binomial, the two things. In this case, 77% of the people believing that the political correctness is a problem. So we're multiplying 6 times 0.77 using a calculator. 6 times 0.77. Okay, we're rounded to the nearest tenth. I'm going to do that right from here. 4.62. The 6 is in the tenth place, but the 2 determines whether or not it gets rounded or stays the same. So here, 4.6 is what we're going to record. 4.6. Alright. The variance, or sigma squared, is found by multiplying N times P times Q. Well, we know N times P because that's the mean. Okay, so you could just take that value and multiply it by Q, or you can just write them all or do them all. 6 times 0.77 times 0.23. Okay. 6 times 0.77 times 0.23. 1.0626. Remember, we're rounding to one number after the decimal. Well, that would be here at 0. But in order to be sure I'm rounding properly, I look here to the second digit. 6 is higher than 5, so it makes that 0 become a 1. So we're recording 1.1 as our variance. Okay. Remember, the standard deviation is found by taking the square root of the variance So I'm going to take the value before it is rounded, which is 1. I'm going to put the whole thing in the calculator just to be on the safe side. 1.0626. That's what I remember from my calculator. And so let's calculate the variance. I'm sorry, the standard deviation. Second, 1.0626. Let's look at that. If we're rounding that to the nearest tenth, I see 1.03. That 3 does not make this 0 become a 1. So I'm recording the standard deviation as 1.0. Okay, so we found the mean of a binomial distribution. Remember, the formulas are different for if it says the probability distribution. We use a different formula. the variance and the standard deviation. Now we're asked to interpret our results. Let's look at the next part of that, this bottom portion. Most samples of 6 adults would differ from the mean by no more than blank. So what are they really asking about? What separates the mean? Like, how do we? So they're asking really which one of the other values that we calculated tells me how far things separate from the mean. Well, that will lend itself to deviation. So we sampled 6 adults, and they would differ from the mean or the average of 4.6. They would deviate about one. So they're really asking for the standard deviation there. So let's highlight that. Would differ from the mean. They want to know about that standard deviation. .0. Okay. All right. Last one, and it is similar to our problem with our binomial distribution using our PDF or our CDF functions. Okay. So let's look at number 13. %% of consumers prefer to purchase electronics online. You randomly select 8 consumers. I'm sorry, y'all. Find the probability that the number of consumers who prefer to purchase electronics online is exactly 5, more than 5, or at most 5. Look at what that looks like. Exactly 5, more than 5, at most 5 or less. Let's talk about which one of the binomial programs, the functions, will we use for this one. You should be able to determine that yourself. So in P of 5, will I use PDF or CDF? You're right, we need to use binomial PDF. Exactly a number. For this one, will I use CDF or PDF? If you said, well, first we have to rewrite it, absolutely, and then we will use the CDF. So right, you're right. Binomial CDF. And then here, lastly, will I use PDF or CDF? Yep, I'll use the CDF because it's already written as using the inequality symbol less than or equal to, CDF. So I believe that you should be able to do this one on your own. You can refer back to your notes from problem, I believe it was 8 or 10, and calculate that that value. So I'm simply going to write that answer here, 0.219, and that is rounded to 3 places. Okay, I do want to work through this one though. So let's think about x is greater than 5. P of x is greater than 5. What are those numbers that are greater than 5? They include, I'm sorry guys, I don't have y'all in here the same as times I can't see that. Okay, so x is greater than 5 includes 6. It does not include 5. Okay, it includes 7, and then it includes 8. I stop at 8 because we know that n is equal to 8. That's the max. N is equal to 8. Okay, so we need to rewrite this using a less than symbol. and then find the complement. Well, if I want these numbers, that means I'm not using, what numbers are we not using? Numbers not included. Then we're talking about 5, 4, 3, 2, 1, 0. How can I write an inequality statement to represent 5, 4, 3, 2, 1, and 0? Well, that inequality statement would be x is less than or equal to 5. So now we can find the probability that more than 5 of the randomly selected 8 consumers prefer to buy their electronics online by subtracting this from the complement from 1. Subtract 1 minus the probability of x is less than or equal to 5, using that CDF function in the calculator. So let's go to our calculator. Okay. 1 minus second bars, and I want CDF this time. So what was our number of trials, or our randomly selected number? That would be 8. The probability that they do prefer was 50%, 0.50 or 0.5 or 0.5, however you want to key that in. And since we're finding the CDF, we're using less than 5. Close that parenthesis. So right from here, y'all, we're trying to round to 3 decimal places. Let's look at the 4th decimal place. 1, 2, 3, 4. The 4th decimal place is a 5. 5 will bump that 4 up 1. So what are we recording? 0.145. 0.145. Okay. So that was part B. For part C, P of x is less than or equal to 5. Remember, you got options. You could find the probability of 5 exactly, 4, 3, 2, and 1 exactly, and find your answer. We also should see that if the probability, if we look back here, we just found that the probability of 6, 7, and 8 inclusively was this number. I should be able to subtract this from 1 and get this value. Let's do that. And then we're still going to calculate it. So 1 minus 0.145. So, I'm sorry, y'all. Look at that answer. Let's keep that in mind, because when we subtracted the previous response, because they're complements of each other, we got 0.855. Let's see if that really works out that way. Okay, so it's already in the less than form, so we can use the CDF function. We don't do the 1 minus this time, so let's do second bars. We need the CDF. Enter. The number of people is 8. At 50%, and 5. Oh, guys, look, it worked out. So, the probability of less than or equal to 5 people preferring to buy their electronics online is equal to 0.855. All right, guys. So we have completed 3.2. Today is 3/26. That means that your homework and self-check for 3.2 will be due on 4. I'm sorry, not 4. Not 4 yet. We ain't doing that far. Today's the 26th, so the next 3 business days, Monday, Tuesday, Wednesday, that'll be 3:30 by 11:59. Remember, module 3 exam opens today. So the window is 3/26 through 4. I think I put it at 4/1. I'll change that to 4/2. 4/2. I think that's a Saturday. You have 2 by 11:59. No, not by 11:59. Not if it's gonna be due on Saturday. It'll be due by class, so by 11 a.m. on 4/2. Y'all see that? Okay. And you have 2 attempts. The password for any assessments is MATH, all caps, 1530. Alright, I hope this video helps, guys. Have a good weekend, or have a good week.